So lesson 81, solids of resolutions 2. So lesson 2, and this is our washer method. Now, it's not that you're going to be told, oh, washer method or disk method. This is where you have to graph it and you'll find out once you graph and look at it. Obviously, today we're just looking at washer method, but moving on, it's not that they say use the washer method, use the disk method. You have to notice they'll talk about revolving around an axis, and you'll have to look at the graph. I already mentioned, for disk method, we just did pi times the function squared, and we did the integral of that. And our function ended up being the radius, because the function is, okay, how far are we from whatever axis we're revolving around? The idea here, okay, if you look at this circular region, if we just think area for a moment, how are you going to find the area of the donut, of the onion ring, of the washer, of whatever we want to talk about, right? So how are we going to find the area of that? You're going to find the area of the whole big one minus the area of the inside one, yes? And that would find the area of the shaded region. Well, that's basically what we're doing. Except when we talk volume, of course, it becomes an integral, and we're multiplying by pi. Well, and that's part, so basically you're doing, so pi r squared of the big one minus pi little r squared for the small one. To shortcut those, we can go ahead and put the pi out front, and it's big radius squared minus little radius squared. Okay, you still, of course, find your boundaries. We can work in x's or y's. It's the same idea both ways. So this is the format we need to be familiar with. Ready to try it? I mean, it's not going to make sense until we actually look at one, is always my feeling here. So let's make it make sense. Find the volume. Right there, guys. You see volume, yes? Of the solid formed by revolving the region between y equals 2x squared, y equals x squared, and y equals 4 about the y-axis. So y equals 2x squared, y equals x squared, y equals 4 about the y-axis. Okay, so we should probably think about the graph. Y equals 2x squared versus y equals x squared.
One is a parabola, the other is a stretched parabola.
Okay, so they're both parabolas. Parabola versus the 2 is going to be a stretched parabola. So it is important to know, obviously it's going to be a parabola sitting inside a parabola, right? It is important to understand, okay, which one, if I basically draw, how fancy do I need to get? I don't need to get fancy here, do I? I'm going to kind of over-exaggerate this. I don't like that. Hold on. I'm over-exaggerating this for the purpose of what we're doing here. Wow, that's an ugly parabola. Okay. Okay. Well, the right half of the parabola was not very good on either of those, but which one is x squared, which one is 2x squared?
The slimmer one is 2x squared.
Okay, because it's 2, it's a number bigger than 1. It's going to be a stretch. It's going to go up quicker. So the inside one is going to be your 2x squared. The outside one is going to be your regular x squared. Does that make sense? And that's important to be able to figure out without looking at the calculator, because that's something they would expect a calculus student to be able to figure out. Okay? We are rotating about the y-axis. Oh, it also mentioned what? I graphed 2 of the 3. y equals 4. Y equals 4 is what?
Horizontal and white.
Yeah, it is a horizontal line at y equals 4. So basically the whole point of y equals 4 is that's my upper boundary, isn't it? So, what is revolving here?
The little area in the middle between the two parameters.
This piece between my two parabolas, yes? Now, technically, they could have limited us down to the first quadrant, because what we're looking at right now here versus if I just had the first quadrant, it would be the same shape. But being that we're rotating around the y-axis, it doesn't matter. Okay? So that's what we look at. Let's see, things to think about. Being that this is in terms, we're rotating around the y-axis, our integral is going to have to be in terms of y. So one of the things I would suggest you do is let's get both equations in terms of y. Okay? So one of them being y equals x squared. I'm going to reverse that and say x squared equals y. If I solve that for x and make it x equals, x is the square root of y for one of them. What about the other one?
It would be y over 2, square root of y over 2.
Yeah. If it's 2x squared equals y, and we solve that, divide by 2, so x squared is y divided by 2. X is the square root of y divided by 2. And I'm just going to leave it in that not pretty form. In my opinion, important to determine going forward, because we have to know which order to put these in. Which one's big R? Which one's little r? In terms of big R representing the outside, little r representing the inside, because we're going to do outside minus inside. Okay? Kind of like when you do upper minus lower, right minus left. It's the outside minus the inside, or farthest from the axis minus closest from the x-axis, or y-axis in this case, excuse me. So what's my big R and my little r? My outside graph is y equals x squared, so x equals square root of y, so this is going to be my big R, my outside radius, and this here, x equals square root of y over 2 is going to be my little y.
Why is it plus or minus?
Plus or minus, we would need plus or minus, let's see, let me process through. The minus would be the part below the x-axis.
Okay.
And we're just talking about the part above. Okay, we ready to find volume? Okay. Volume equals, what am I going to start with? Pi. Remember, multiple choice, they'll throw in answers without pi that look just like the right answer. What about my boundaries?
0.
We're working on the y-axis. We're wrapping around the y. So we are going 0 to 4. Big R squared minus little r squared.
So square root of y squared.
So big R, the outside radius, being square root of y squared, minus the inside radius, which is
Square root of 2.
square root of y over 2 squared, times dy. Are we okay with that setup? Okay. I don't know about you guys, but I would definitely, before you integrate, you want to, and especially in this case, we're going to square root. What happens when we square root?
You just get the inside.
Yeah. I'm going to have y minus y over 2. Well, that's looking a lot nicer, isn't it? Still pi. I'm ready to integrate. What is the integral of y?
1/2 y squared.
Okay, because we're integrating 1y. So this is, oh my goodness, hold on. Well, okay, we can go ahead and integrate here. There was actually one more simplification step we could have done here if I'd caught it.
Take out 1/2. Or negative 1/2.
It's not take out the 1/2 as much as,
Just separate.
I don't know. This is 1y minus 1/2 y.
It is one.
They're like terms, aren't they? 1y minus 1/2 y is going to be 1/2 y. Am I saying you had to do that? No. But we'll only have one piece to plug into later instead of two pieces. And obviously it's easy to overlook because I just about flew right past it. Had I not glanced at my notes, I was like, wait, what? I would have missed it. Now, that 1/2, we can leave it either way, but we've got the pi out front. What's the integral of 1/2 y? Not just y squared. Becomes 1/4 y squared. Because if we leave out the 1/2, the integral of y is 1/2 y squared times the 1/2 that's already there, so that really makes it 1/4 y squared, if you will. Evaluated from 0 to 4. Now, pi is a constant. Keep him out front. 1/4 is a constant. You don't even have to put the 1/4 in this problem. All you have to fill in is the y squared. Does that make sense? If I say I'm going to do pi times 1/4, and then now fill in your evaluating. Because all you have left to evaluate is y squared, right? So if I'm evaluating y squared, it's going to be 4 squared minus 0 squared. Four squared minus 0 squared is going to be 16. 1/4 of 16 is 4, times pi is going to make this 4 pi units cubed. Obviously, lots of different ways you could have gone there in the middle, yes? Questions? Did it all work out one way or another for you? That was the first one. You might not have been too far ahead of me, but. Okay, ready for the next one? Find the volume of the solid formed by revolving about the y-axis, the region bounded by y equals x equals 4, and the x-axis. So because we're revolving about the y-axis, we are going to have to work in terms of y. Just kind of an FYI there. Let's see, what do we have here? Y equals x, which is That lovely diagonal line goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. X equals 4. What's x equals 4? That's a vertical line. And the x-axis. What is it that is bounded here? That little triangle there, yes? And we are rotating this triangle about the y-axis. Kind of going to form like a bowl shape, right? Let's see. If we're working in terms of y, well, y equals x is x equals y. X equals 4 is x equals 4, right? In other words, they're already, there's not any fancy solving we have to think about here. So, okay. Volume, V equals. What do I start with? Got pi. I don't know, is it?
Because that would intercept that point up there would be 4, 4.
Okay, and here's the key. When we talk about this, realize we're rotating about the y-axis, aren't we? So this is why I'm not just letting Ross say 0 to 4, because is it this 4? No. We're rotating around the y-axis, so we're working this problem in terms of y, so we need to realize what is that ordered pair? Well, on y equals x, that ordered pair would be 4, 4, wouldn't it? So I do agree it's 0 to 4. But I want you to make sure, don't just grab the 4 that's staring at you. It's technically the other 4. Does that make sense? Okay, so it's from 0 to 4 on the y-axis. Big R squared minus little r squared. Outside function minus inside function. What's the outside function here? X equals 4, yes? That's going to rotate around the outside and create the outside barrier. What's the inside function? X equals y, right? So that's what we're going to be subtracting off, because that's going to create the inside barrier. So I'm going to be doing 4 squared minus y squared. Okay. Good news is the math is not too bad here. Pi times the integral from 0 to 4, and I'm going to say of 16 minus y squared. Keeping my pi out front. This time I'm going to double check, but I can't subtract 16 minus y squared, so I am ready to integrate. Integral of 16 is 16y minus the integral of y squared is 1/3 y to the third. Evaluated from 0 to 4. Are we okay with that? Okay. Plug in 4. So 16 times 4 minus 1/3 times 4 cubed minus, then I'm going to plug in 0. 16 times 0 minus 1/3 times 0 cubed Well, 16 times 4 is 64 minus a third of 4 cubed. Wait a minute.
It'd be 48 over 3, right?
It is 48 over 3, isn't it? Oh, and that does divide, doesn't it? Okay, sorry. I was processing as I went there. I guess I was struggling with what is 4 cubed. It was not happening up here. Okay, 4 cubed is 48. That is correct. Because I do agree. 48 divided by 3 is 16. Okay. And 64 minus 16 then is going to be 48 pi? Yeah, no.
I wrote it down.
We went astray.
Oh, no. Get glad.
Okay, let's go back to what is 4 cubed. It's not 48.
Isn't it
It is
60?
64.
That's what I thought.
I'm sitting
Which
here,
is-
I'm
I know.
No, I was like 48. I was like, how is that even?
You guys have the calculators behind.
I don't have my calculator out.
That's a very good point.
You guys have the calculators behind me. I'm trying to do this on the fly. I'm not looking at my notes. My stupidity there, but, you know. Okay. So, okay. We should be doing 64 minus 64 thirds, which means if I'm doing this without a calculator, which is obviously a bad idea for Mrs. Sargent today, but if we're doing this without a calculator, I'm getting a common denominator of thirds. What? Okay. So I went with common denominator of thirds. 3 times 64. Okay, that makes sense. 192 thirds minus 64 thirds. 192 minus 64. $128. 128 thirds. Somewhere put a pi in there, right? And then units cubed.
You did it.
I know.
You know, the thing is,
My notes were looking good.
I'm not messing up the big picture.
And then,
I'm messing up the little stuff today.
Yeah, I mean, the numbers
Didn't
are
you say
important
last
setup.
year that was the joke, was like algebra is harder than calculus?
Oh, there are so many memes you can find that what's the hardest part of calculus? Getting the algebra right. I mean, there are so many memes you can find like that. So I'm getting the idea across, right?
Yeah.
Forget the fact I can't do the little math today, and you guys aren't helping me out very much. You guys aren't catching
Ross
me.
said it and you backed him up and I was
Well,
like,
listen,
maybe I'm doing
when I
something
did it
wrong.
on the calculator, I was like, okay, 4 times 4, 16, and I multiplied by 3 instead of 4.
Okay, that's why I know what. Okay, I knew you had your calculator out, but okay. Example 3. We got 2 more examples here, guys, and we have yet to rotate about the
Z-axis.
X-axis.
we have
Z. Whoa,
If we
no,
get to Z,
no,
what level of calculus is that?
I don't know.
Mrs. Rogers told me about.
I want to say Calc 3 in college was
So I will never see the Z-axis.
maybe 3-dimensional. I don't know.
Let me know how
I can't remember.
I'm gonna call you.
Okay.
I'm gonna be like,
Find the volume of the solid formed by revolving the region between y equals x squared and y equals square root x about the x-axis. We actually saw this revolving already, actually, now that I think about it.
Yes, that was 3-dimensional.
Yeah.
Abby's mind is blown.
Abby's little mind is full right now.
We just took her to overload. Okay, y equals x squared. And notice it did say, well, it doesn't say just first quadrant, but y equals square root of x is only in first quadrant. So
It's our only option.
it's our only option. There's y equals x squared. There's y equals square root of x. Obviously, if you graph these on the calculator, they might be a smidge different, right? I'm just going with what my brain knows. And that's all you have to do, is to get the basic idea. We are revolving about where? The x-axis, which means we don't have to change these, do we? We're already in the right form there with y equals x squared and y equals square root of x. We do need to talk boundaries.
Yes, we do.
Boundaries are on the x, so we need to talk here.
It should be 0, 1.
Yeah, because think about where are the square root of x and x squared going to intersect? And that is going to be the ordered pair 1, 1. Because the square root of 1 is 1 and 1 squared is 1. So that is a 1 there. Okay. Oh, dang it. I did the first part for you. I filled in pi.
So we're just taking the rotation of that little leaf in there.
Yeah, so I guess I didn't, looks like a little leaf there. Okay. I think this was actually the last video I showed. So,
It's like a taller dome looking thing.
yeah.
Oh, the bowl.
Yeah. Okay. What's my boundaries?
0.
0, 1. This is important. Big R squared minus little r squared.
X squared is outside. No.
Because which way are we rotating this? We're bringing it down along the x-axis. Are you- Okay.
She's a ball.
Okay, so this is the first one. So if we were going around the y-axis, we'd be going around the vertical axis, and I would agree that x squared would be in my outside function, and square root of x would make the inside. But we're not doing a vertical thing, we're doing a horizontal thing. And so when I rotate this around the horizontal x-axis, square root of x is that upper boundary. So this is going to be the square root of x squared minus x squared squared. Okay? It's outside radius squared minus inside radius squared. That's what you've always got to think. So we're okay with this now? The math on finishing this one up shouldn't be too bad. So it's pi times the integral from 0 to 1. Square root of x squared is going to be x minus x squared squared is x to the 4th times dx. Not like terms, so I can't subtract them. So pi out front still. The integral of x is 1/2 x squared minus the integral of x to the 4th is 1/5 x to the 5th. Evaluated from 0 to 1. I'm glad we only have to plug a 1 in here. So pi is out front. Plugging in 1, 1/2 times 1 squared minus 1/5 times 1 to the 5th minus 0 squared minus 0 to the 5th. Basically, you just have to be able to do 1/2 minus 1/5. 5/10 minus 2/10 is going to make this 3/10 pi units cubed. Or 3 pi over 10. Okay, one more. the region between the graphs of y equals x squared plus 2 and y equals 1/2 x plus 1 on the interval 0 to 1 is revolved about the x-axis. Find the volume of the solid of revolution generated. Notice x-axis. Okay, got a picture of what this is looking like? What is y equals x squared plus 2? Okay, parabola, moved up 2. So I'm going to go up 2 on the y-axis and make my parabola. It's on the interval 0 to 1, so I just made my first quadrant parabola. What about y equals 1/2 x plus 1?
That one's like,
Why it'd be a diagonal.
Y equals mx plus b. Y-intercept of 1 with a slope of 1/2. So rise 1, run 2. Puts us going through, we start there. We also are going to go through 2, 2. We are specifically on the interval 0 to 1. So what's that mean we're doing here? Look at this little piece right here. Rotating about the x-axis. Interesting looking shape, right? Especially if you try to visualize the 3D here. Are you throwing things back there?
Yeah, I still popped it off a while ago. I was sitting here doing a problem, right? I just see the pin cap.
Well, see, I was trying to open it with one hand, so I was like this, and it just.
He's trying to assassinate Ross. That was an assassination attempt.
I missed. All of a sudden, you just wander up and pick something up off the floor and return to your seat. So, okay, guys, there's my help.
Thank you.
Hallelujah.
It is much appreciated.
Okay, what am I writing next?
Pie.
Oh, there we go. Hey, I've been putting the pi in for you guys without really asking, so I need to be asking. Okay, what's next? Integral from 0 to 1. Okay, there we go. Now you guys have to continue.
It's your turn.
Okay, so, outside. Oh my God.
Which one's the outside, Ethan? Going to
This
go.
is the
It's the
x-axis.
x-axis.
This is probably like the top one. It's like y equals x.
Yeah. Maybe a way to think about it, when you're rotating about the x-axis, you're going to want to do upper minus lower. Unless, of course, you're below, and then it's...
See,
Yeah, see, that's why I can't say upper minus lower. It's the outside minus the inside.
Yeah, I can.
I can picture it.
Okay.
Here we go.
And that's... You have to visualize some here. It is so hard for me to... Yeah, so the idea is this little chunk thing is going to rotate around. So it is the upper one. So x squared plus 2 squared minus
Oh no.
1/2 x plus 1 squared dx.
He smells like great.
Your smeller is working quite well then, because we are definitely going to be doing some fun. Is that what Ethan's oh no was?
Yeah.
Okay, well, let's boil away. X squared plus 2. X to the 4th. 2x squared and 2x squared is going to be 4x squared plus 4. minus, if I put this next piece in parentheses, 1/2 x times 1/2 x, 1/4 x squared, 1/2 x plus 1/2 x is going to be 1x, and 1 times 1 is 1. And notice I didn't actually subtract right there. I was just trying to FOIL. Or did I FOIL too quickly?
It's all removed.
The joys of calculus. I don't have to write out all my FOILing finally. Before I integrate, surely there's some kind of like terms here, yes? I would consolidate so I'm not integrating 6 terms. So it's x to the 4th, 4x squared minus a 4th x squared. My brain wants it 4 minus a 4th. My brain is saying 3 3/4. But then my brain knows that I need it to be improper. So 3 3/4. 15/4. Sorry, I needed the visual. So I'm going to say 15/4 x squared. There's a minus x. It's not being subtracted from anybody. And 4 minus 1 is plus 3. Did I do it?
Wow.
Hey, we match with the answer key. Or we match with my notes here. Which normally I don't necessarily feel the need to check, but today I do. Whew. Okay, integrate. Integral of x to the 4th. 1/5 x to the 5th. So integral of x squared is 1/3 x cubed.
This would be 15 over 12.
15 over 4 times 1/3 is going to be 15/12 x cubed. You could technically reduce 15/12. I will probably do that next time. Minus integral of x is 1/2 x squared plus integral of 3 is 3x.
It's a good thing it's only from 0 to 1.
Exactly. There are small things to cheer on here. Okay, plugging in the 1. 1/5 plus, I'm going to reduce 15/12 to 5/4 minus 1/2 plus 3. And then, is my other side all zeros? Okay, but you double checked that, right? You didn't just assume it was all zeros. To not use a calculator, I'm going to say, okay, common denominator. 5, 4, and 2 all go into 20ths. So 1/5 is 4 20ths. 5/4 is 25 20ths. 1/2 is 10 20ths. And 3 is 60 20ths. That's doable for my calc kids, right? I didn't say it was a piece of cake for fun, but you know. So 4, 25, and 60 is 81. No. Yes? 85. Plus 4, 89. Minus 10. Is it 79?
Yes.
79 20ths pi units cubed. Just about made another mistake in there, but
That was definitely an interesting lesson.
The doozy for sure.
She was cute. I liked her. That's my whole donut.
so now we're all hungry because you've been thinking about donuts and
What is
Yeah.
for lunch?
I woke up hungry today.
taco
I
something.
normally don't do that.
Taco bites?
Hopefully not taco pizza. 'Cause that's
Oh,